Good afternoon. We're going to be presenting to you the Anaphylactic Shock. We named a roller coaster the Anaphylactic Shock because, as you may not know, anaphylactic shock is the allergic reaction due to a bite of a poisonous insect, such as a bee or a scorpion. So the thrill you will feel in this roller coaster is almost the same effect, has almost the same effect as an anaphylactic shock. So in this roller coaster we can see many physics principles.
And the most basic principle of physics that we can see is speed. Speed is the measure of distance over time. To measure the speed in this roller coaster, we first have to find the speed of the climb, which to do this we found the distance of the climb, which is 1.34 meters, and the time it took for the cars to do the climb, which was 19 seconds. And with these numbers, we found out that the speed of the climb is 0.076 meters per second. And then we found the speed of the cars during the fall. We found first the distance of the fall, which is 3.54 meters, and then the time it took for the cars to fall, which is 2.1 seconds. With these numbers, we found that the speed of the fall is 1.7 meters per second. Then we used these numbers and compared them to the fastest roller coaster in Busch Gardens, which is Cheetah Man. Cheetah Man reaches a speed of 97 kilometers per hour, and then we converted this number into meters per second to compare it with our roller coaster, which is 26.9 meters per second. And then we have acceleration. And the acceleration is just the measure of speed over time. To find the acceleration of the climb in this roller coaster, well, the acceleration is zero since the velocity is constant when the cars are going up. Then we found the acceleration of the cars during the fall, which is 0.81 meters per second. Since we divided the speed of the cars falling, which is 1.7 meters per second, over the time, which is 2.1 seconds.
So not only can we see acceleration speed in this roller coaster, but we can also see many forces. Starting with the gravitational force. The gravitational force can be seen as a weight. The weight here is the weight of the tracks and the weight of the cars. To make sure that neither the tracks nor the cars fall due to the weight, we need to apply a force that is equal in magnitude, however opposite in direction. So we apply the normal force, which is the force perpendicular to the force of gravity. We can see how we apply the normal force in the base. Here, we see a 90 degrees base that is keeping the tracks from falling. We can also see the force of friction, in this case kinetic friction. Kinetic friction is a opposing force of an object in motion. So kinetic friction is what slows down the cars. So for example, the cars tended to slow down in the curve, such as that one, this one, or this one. However, we applied lubricant oil to reduce the force of friction. By reducing the force of friction, the cars would pass more smoothly and would make the cars travel faster. We can also see inertia here. Inertia is a tendency of an object to move in a straight path with a constant velocity. We can see inertia because the cars, they move, they tilt either to the right or to the left because of inertia. The tendency to move in a straight path is what makes them tilt.
So besides acceleration, speed, and forces, we may see the concept of energy. In this roller coaster, we see three types of energy: the potential energy, the kinetic energy, and the mechanical energy. Potential energy is simply the energy that depends on the force and the position of an object. At the top of a path, we see gravitational potential energy, which is energy depending on the force of gravity. As it moves down, as the car goes down the roller coaster, the potential energy converts to kinetic energy, which is the energy due to motion. As we may see, since it goes from the top to the bottom, potential energy is converted to kinetic energy. Now, mechanical energy is the sum of these two forces mentioned. Mechanical energy is always conserved in this roller coaster, since the potential energy initial plus the kinetic energy initial is equal to the kinetic energy final plus the potential energy final, as I explained in the conversions.
So we can also see simple machines here. We can see the wheel and axle, which is the wheel that is turning the engine and bringing the chains up. The cars up by pulling the chain. So these are the most basic physics principles we can see in a roller coaster. However, much advanced principles can be seen. Thank you for watching and have a nice day. Que silêncio.